Okay, everybody, moving along. What we're going to do is take what we know now about oxidation and reduction, table J, spontaneous reactions, losing and gaining electrons, and let's just put this thing to use. Let's take it and make something that we can use in technology, and that would be something called the common battery. All right, basic batteries use chemical energy to create a flow of electrons. So let's just examine how this works. And see the inner workings of this. So what we can do is we look at something called a voltaic cell, or sometimes it's called a galvanic cell. This comes from Alessandro Volta, okay, and Galvani. Galvani is also a scientist that is attributed to this. So, and we look at common batteries such as alkaline batteries or portable batteries like this, or we even have lead acid batteries, like batteries that would be in a car. All right, so to do this, to make just a really crude type of battery, what we normally do is have two beakers, okay, or two cells. Sometimes we call these cells. All right, and this would be half cell one. We call this half cell two. So what we're going to be using is we're going to be using zinc and copper. All right, so simply what we do is we take a solution of zinc sulfate and a solution of copper sulfate, and we place those in the two beakers. All right, and again, you would have in this, you would generally have zinc 2 plus, and sulfate would be 2 minus, copper would be 2 plus, and this would be 2 minus, and this would again be in the liquid. Okay, and what we do is in this liquid we will put a piece of zinc. So this is actually zinc metal. So this is zinc metal, and this is a piece of copper metal. All right. And then we're going to connect them with a wire. So this is a piece of wire here, okay? And we have a glass tube here. A salt bridge is going to be a glass tube, okay, that connects the two, all right? And inside are electrolyte. So there's an electrolyte in here, and we're going to go over what that is in here. A glass tube with ions, all right, is inside the tube. So I just want to make sure. And there's actually a blocking here, or a paper towel, or a little piece of gauze, and that prevents any of the liquid from coming out of here. So this is filled with liquid. So filled with liquid ions in this glass tube. You have a zinc solution here, a copper solution here, okay, and you have a piece of zinc metal here and a piece of copper metal here. So copper in a copper solution, zinc in a zinc solution, okay, and this is what this kind of thing looks like. All right. So what we're going to do then is what we find is when we connect it this way, we're going to find that electrons begin to flow. Okay, and electrons begin to flow. Now, if you remember from table J, I'm going to put it on the side here, up here, that zinc is above copper 2 plus on table J. So we're going to get a reaction, an oxidation reduction reaction, where zinc will be oxidized, okay, and a reduction below. So as long as the ion is below, the top one will be oxidized, and the other one will be reduced, and the electron flow is in that direction. All right, so what's going to happen is as soon as we connect this, so this is going to be a wire that's connected from one to the other, we're going to have zinc 0 become zinc 2 plus, and it's going to lose 2 electrons, okay? So that zinc is going to go and become 2 plus. The 2 plus goes into the solution, okay? So it comes off the panel, off this piece of metal. It goes into the solution, okay? And what's going to happen is the 2 electrons that are lost are going to be stuck on the panel, because electrons can't swim, okay? They don't have floaties. So they can't swim. So they're going to be stuck on this panel, okay, which gives this piece of metal a negative charge. So the negative charge of a battery is really this part where oxidation takes place, okay, where the top of table J, or the top element. All right, so what's going to happen is electrons don't like to be with each other. So as you create more and more zinc 2 plus in the solution, and more zinc 2 plus in the solution, and more zinc 2 plus in the solution, and you get more and more of this, you get more and more electrons. And eventually, what they simply do, okay, is they flow to the other piece of metal. Now, why do they do this? That's because you're having a buildup of electrons here and less of electrons on the other side. So because we have less electrons, or we have a less negative area on the other side, that becomes the positive side of the battery. So the negative part of the cell is the zinc part. The positive part will be the copper part. So if you're looking at table J, the top metal would be the negative part, and the bottom part would be the positive part, bottom element. All right, so electrons are now going to march through this wire, and they're going to show up to the other side. And as they show up to the other side, we know that there's copper 2 plus in the solution from when we made it. So what's going to happen is as those electrons show up here, all right, copper is going to go over and gobble up those 2 electrons, okay? And other coppers are going to go and gobble up electrons that are coming from the other side. And again, copper is going to go and jump on the panel, and copper is going to go touch. Now again, these have to touch the panel. Again, this is dipped in there, so it's in contact with the solution. So the copper ions are going to be able to go and touch this. As long as they're swimming around, they can touch. They're going to touch the panel. When they touch, they're going to pick up these 2 electrons. Okay? So what's going to happen is in the reaction is that copper ions will be reduced. Again, reduction is gaining. So you're going to get copper 2 plus ions are going to take the 2 electrons, okay, and they're going to become copper 0. And copper 0 is new metal. So these copper ions will become part of this piece of metal, and this metal will begin to get heavier. So as the other part becomes lighter because you're losing zinc from the panels or from this electrode, here you're going to get heavier because you're gaining electrons from onto the electrode. All right, so it's understandable that this is oxidized. That's the thing that's oxidized. Okay, and the copper 2 plus is the thing that's reduced. Okay, now electrons are going to continue to do this. They're going to continue flying across here. Now again, as long as you have, let's just say you put a little light bulb in here. If you put a light bulb in the wire, this light bulb is going to light. If you put a cell phone in the wire, the cell phone will work, right? If you put anything in the path of this electron flow, you will power that device, and that's how batteries actually work. They power the device, okay? You could hook a car, you'll see in this diagram, in the 2 diagrams that you see here, you'll see that this area is the negative part of the battery, and this part is the positive part of a car battery. Electrons come out of the negative, and they go back to the positive, so they will help power the parts of your car. In batteries like this, you'll see the positive end is up here, the negative end is down here. So electrons will flow out here, and whatever you put in the way here will be powered by the battery because the electrons will do the work. All right, so just to finish up some of the parts of this, okay, what we call the negative side of the battery here, this piece of metal is called the anode. Okay, and an anode is always where oxidation takes place. The anode is the negative side of the battery, and that's where oxidation takes place. So we can use the little memory device an-ox. An ox is, like a bull type of animal on a farm, a large bull type of animal with horns. We call that an-ox. So an anode is where oxidation takes place. It's going to be the negative side of the battery. Okay, this is going to lose mass because you're going to be losing zinc metal. Okay, because zinc metal becomes zinc 2 plus that goes in the solution. Okay, and if you lose zinc metal, then this has to become lighter. All right, and the anode is always the higher metal on table J. Okay, if you're using the 2 metals on table J. Okay, the second thing, okay, the other side, the cathode is this piece of metal. The cathode is where reduction takes place. Cathode would be the positive end of the battery. Okay, and we use the term red cat sometimes for this, or Roman Catholic sometimes is used. So red cat would be reduction at the cathode. Okay, and the cathode is going to gain mass because you're getting new copper 0 metal. So is being formed, and as it's formed, it starts to coat the cathode, increasing its mass. All right, so that's important to know. Okay, you have your half reactions down here, zinc 0, zinc 2 plus is 2 electrons. And again, these are the same 2 electrons that are gained here. So that's your flow from one end to the other. Here's your oxidation, here's your reduction. Okay, so some notes along the way on this so we can see how we're doing. Okay, some notes along the way. Okay, about the salt bridge. What does a salt bridge do this? Well, important to know that what will happen is that the salt bridge allows think about the salt bridge as a highway for ions. Okay, and the reason this takes place is because in this solution, as this runs, if you notice, I'm making a lot of positive charge. So a lot of positive charge is generated as these zinc 2 plus ions dump into the solution. okay? But I'm not putting any more negatives in. So this solution starts to get positive. We don't want that, okay? On this side, copper 2 plus ions are leaving the solution, okay? But I'm not adding any more. I just have sulfate ions there. So this becomes a negatively charged solution. We don't want that. Now, why don't we want that? Well, if this solution, the solution part is positive, then electrons are not going to leave. They won't go to the other side because they're attracted to the positive charge. They also won't go to an area where it's negative. So what we need to do is we need to keep these cells neutral. So what we're going to do is in the salt bridge, positive ions are going to flow through the salt bridge, and they're going to negative ions are going to flow through the salt bridge, and they're going to equalize the positive 2 plus. So again, I can use sulfate ions for those. All right. So sulfate ions will flow from this side and go in here. Again, they could flow from here too. They're going to go here, and they're going to go into the solution. And for every 2 plus, we're going to get a 2 negative, and that's going to make this go away, be 0. So we want to keep the cells neutral. On the other end, positive ions are going to flow this way, okay? And they're going to replace the positive ions that are leaving, okay, the solution. So I could easily use sodium sulfate. So sodium ions will flow this way and go and replace the copper, and sulfate ions will flow that way. And that's how the salt bridge keeps these cells neutral. So that's how the salt bridge works. It's a highway for ions to flow. All right, so what's your summary? Your summary of the whole thing is this. We basically have an oxidation and a reduction, and we have an electron flow from the anode to the cathode. And this is going to happen spontaneously, on its own, electrically. Okay? We're also going to get a chemical energy in chemicals that's going to be converted to electrons, and electrical energy. So electrical energy is available to us to power a device. So we're taking chemicals and creating electricity with them. Okay? The salt bridge allows ions to flow, not electrons. It allows ions to flow to keep the cells neutral so that the electrons can flow through the wire. Okay? Again, through the wire. Electrons flow through wires. Okay? Where do they flow? Positive ions flow through the cathode cell. Negative ions flow through the anode cell. Okay, you could think of positive ions flowing through the positive cathode cell, negative to negative anode cell. Okay. Okay, and just remember, last but not least, remember it's the ions, and there's a lot of confusion sometimes with this. Remember, it's the ions in the cathode solution that are actually reduced. Okay, and that becomes confusion because sometimes we would say, the cathode reduction. However, we could say reduction at the cathode. However, the cathode itself here is not being reduced. It's the copper 2 plus ions when they touch the cathode. So think of the cathode as the site of reduction. Okay, this is almost like the site of reduction. All right. Now what I'm going to do is I'm going to do an example of this on the next slide. If you want to stop the video here, you can do that and then practice the next slide and then come back and check your answers. That's probably a good idea to do. Okay, so I'm going to give you the answers to the slide on the next page. I'm just going to jot it out really quickly. However, if you want to stop here, this would be the end of the notes, and then the next slide down would be an example. So I'm going to run that here. So if this video is a little bit longer, that's the reason. Okay, so here we have an example of this. So we'll label some of the parts here, and let's just say we want to build a zinc nickel cell. Okay, and we find out, we take a look at, so the first thing to do is detect table J, and if we look at table J, we're going to see that zinc 0 is above nickel. Okay, so since zinc is above nickel 2 plus, we're going to have this being the anode, okay, and nickel being the cathode. Okay, so we could set up our cells the way we want. All right, so again, we want to allow for the following thing. So number one, let's just make this the zinc side. I'll make this the zinc side. Okay, so this is a piece of zinc 0. Okay, this would be a piece of nickel 0. Okay. Now in the solutions, we would have a nickel solution. Let's just say we use nickel 2 nitrate. And let's just say we use zinc nitrate, ZnNO32, okay? So in here is going to be, well, I kind of messed it up. So I'm sorry, this is going to be nickel nitrate, and this is going to be zinc nitrate. So let's just redo this for a second. All right, so let's just make sure this is zinc now. Let's make sure this is nickel. Okay, that would be nickel. That would be zinc. We're going to use a zinc nitrate solution on this side, confirm the formula. Nickel nitrate on this side, confirm the formula. So we're going to have nickel 2 plus ions in the solution, zinc ions in the solution. Okay, we have our salt bridge here. We always have to have our salt bridge. Okay, let's just say we have a device or a voltmeter. Okay, a meter that registers here what we have going on. We can even use this as a cell phone, maybe. I'm just kind of making this up, or a bulb maybe here. Okay, we could put that in the way of the current. All right, so what's going to happen now? So since zinc is above, again, we looked at that before, since zinc is above nickel, okay, again, we can rewrite this really quickly. We could say zinc, since zinc, okay, is above nickel in the table, we're going to electron flow from zinc to nickel, 2 plus. Okay, so this is going to be the oxidation. This is going to be the reduction. This must be the anode. This must be the cathode. So we know what we're doing here as far as that goes. Again, the general plan. And we simply just have to fill it in. So that's easy enough to do, right? So we took care of our zinc side and our nickel side, took care of our solutions. How about the anode? So the anode is going to be on this side. Here's my anode. Okay, here on this side is my cathode. Okay, my anode is going to be negative. That's where my electrons are going to take off from. They're going to want to go to the positive side, so that's my positive side. So I have my anode in the charge, my cathode my charge. Where oxidation takes place, oxidation always takes place at the anode. Reduction takes place at the cathode. Okay, again, this is going to be your minus. The minus part of the battery is here. Your positive part of the battery is here. Okay, so what's going on with my salt bridge is going to be in the middle. I took care of that. My voltmeter here is here. My voltmeter or your bulb or whatever. A voltmeter is simply a meter that shows us how electrons are flowing. Okay, and my direction of electron flow is going to be out of the anode, always in this direction. So my electron flow is this way. Okay, so that's my E flow. My E flow is this way. Awesome. Okay, my salt bridge, my direction of my ion flow. Well, if you have positive ions being generated here, right? So again, we're getting zinc to nickel 2 plus. Okay, I'm sorry, Zn0. So here at the anode, we're getting zinc 0 going to zinc 2 plus 2 electrons. Those are going that way through the table, through the wire. Okay, and because of that, because you're getting 2 plus going in, we're going to have negative ions flow to meet the positives. All right, so that's going to happen. Negative ions will flow that way. Positive ions will flow this way. Nickel is going to be going onto the panel to pick up the electrons that are coming down here. The 2 electrons are flowing here. Okay, so as 2 plus goes on the panel, as 2 plus goes off, negatives flow in, and as 2 pluses go away, positives must come in here and replace. Okay, so positive ions will go this way. Okay, so ions that way, negatives that way, and that way. So that's going to take place as we go. Now at the cathode, we're going to get nickel gaining 2 electrons and becoming nickel 0. Okay, and that will be our half reactions. There's your half reaction of oxidation, your half reaction of reduction. Okay, so again, zinc is oxidized, nickel 2 plus is reduced. Remember, it's the ions in solution that's reduced, and there, folks, is a zinc nickel voltaic cell. All right, so again, this is the kind of thing you want to be able to do. Again, you can go back and do this on your. I would do this on my own. I would have done this on my own first, and then you can go back and check it. All right. Hope this helps. Have a great day.